Welcome to a new unit called coordinate geometry, and it is a huge unit. It is super important for us, and it's going to take quite a bit longer than the other two units have. We start off though with something that is a little weird. It's knowing the difference between a relation and a function. So yes, your learning target is that I can explain the difference between a relation and a function, and even if you only use this first page is really all you would need. So we're going to get some definitions out of the way so that when we use those throughout this unit, you'll know what we're talking about. So the first thing is an ordered pair, and that's just another name for something you know already, which is coordinate. So it names the location of a point on a coordinate grid, x, y. So if you have an ordered pair like 3, 2, I'll write it. Let's say you have the ordered pair 3, 2, you would just go right 3, up 2, and that's your point. So ordered pair, just another name for a coordinate. And I left a lot of room there for some reason. A relation. So here's where we get into the meat of what today is about. A relation is very simple. It's a set of ordered pairs. And at first that sounds a little more simple than it really is. A line can be a relation. It's a set of ordered pairs. Every coordinate on a line. So if I were to, I know we haven't graphed lines yet, but imagine a line being drawn on a graph. It goes on forever in both directions. Each spot, and there's infinitely many spots in between all these spots, each of these coordinates, or each of these ordered pairs, is in the solution set of that line. So we would mark it off by saying this is the set of ordered pairs. We could have 0, 2. We could have another ordered pair at 1, 3, and just go from there. But there'd be infinitely many, so we don't often label them in a set like that. But that's what a relationship is. It's any set of ordered pairs. You could have just a group of points. Anything will do. A function, though, is very specific. So a function, let me erase all this. It's not too long. A function is a relation, so it's a special kind of relation in which each element of the domain corresponds to one and only one element of the range. Bunch of words there we haven't been familiar with. No two ordered pairs have the same x coordinate. So this definition is going to make more and more sense as we go through. Domain, which is a word they used in the definition of a function, is the set of x values of the relation. So if I were to give you a whole bunch of points, like 1, 2, 3, 4, 10, 11, I just gave you those three, the domain would be all of the x values. So we'd say the domain of this example is 1, 3, and 10. That's the set of the domain values. Range, as you can imagine, is the opposite. It'd be the set of y values of the relation. So in this, using the same example, it'd be 2, 4, and 11. So we'd say 2, 4, 11 in a set. So if you notice I'm using these squiggly brackets, that's how we denote a set. So we might be able to squeeze this in here. So a set is just a group of numbers, or a group of things indicated inside of squiggly brackets. Alright, so we're going to ask a question based on some of that info, and we'll try to bring back some of those definitions to explain ourselves a little better. The first one is the following relation, remember a relation is just a set of ordered pairs, and that's what we have. We have 4 points here, 4 coordinates. Is it a function? Is this relation a function? Why or why not? Well, we kind of need the definition of function. I'm going to bring it over here, make it a little smaller. You can just refer back to your own if you want, but I'll have this here so I can point to things if I need to. So I'm going to remind myself, a function is a relation in which each element of the domain. Okay, let's stop there. Each element of the domain. Well, the domain are the x values. So we're going to try to underline this with my orange marker here. So the domain, and that's what it's asking us to list here, is 1, 2, 3, and 4. Those are all of the elements of the domain. Elements being just like part of the set. The parts that make up the set. Corresponds to. And when they say correspond, we'll label this green. They mean, sometimes you'll hear it mapped to. So sometimes I'll write that down too. Correspond is sometimes referred to as maps to. So what the corresponding part is, 1 corresponds to 5, 2 corresponds to 10, and so on. That's what they mean by correspond. They're like partners. They go together. All right, it corresponds to one and only one element of the range. So again, element of the range. It doesn't, for some reason, have a thing here for range, so I'm going to say list the range. And the range, in this case, are the y values. So I'm going to list them here in a set. 5, 10, 15, 20. Alright, so what we want to have happen is that 1, which is an element of the domain, is mapped to 5, which is an element of the range, and that's the only thing 1 is mapped to, or that's the only thing 1 corresponds to. So if you notice, 1 goes to 5, and I don't see 1 happening anymore throughout this whole set. So we're okay there. 2 only goes to 10. It doesn't go anywhere else. 3 only goes to 15, and 4 only goes to 20. So it sounds like we have a function. There's also this other thing at the end. We can restate this. No 2 ordered pairs. So there's 4 of them here, remember. There's these 4 ordered pairs. No 2 of them have the same x-coordinate. And they don't. It's all unique. 1, 2, 3, 4. So is this a function? Yes, because none of that happened. None of that repeating happened. So is it a... Oh. I wrote that in the wrong spot. I meant to write yes right here. It is a function because it says, do any of the numbers in the domain repeat? No, they do not. And our explanation can look like this. The relation is a function because the domain does not repeat. Now we could say it a little bit longer too using the definition, but this is fine for now. The relation is a function because the domain does not repeat. And we'll look at some examples where the relation is not a function. I know that's a lot of new language to take in. It might be worth watching that one more time now that you have a semi-understanding. So I would go back and watch that, just that part one more time. You can fast forward even through it. But we're going to try something new now. Alright, so basically the same question. Number 2. The first they want the domain, so it's just a simple list the domain. The domain is 1, 1, 5, 3. I just did it in the order they gave it to me in. And the range is 2, 4, 6, 4. And then ask, is the relation a function? Well, for it to be a function, 1 goes to 2, and it can't go to anything else. But in fact, I see here it goes to 4. It's kind of like saying, is this a reliable thing? If I throw an input in, sorry, interrupted by announcements. So if I throw 1 into this function, it will spit out sometimes 2, sometimes 4, and it's not predictable. So that's a problem, and it's not a function. So we say no, because very specifically 1, actually we'll use the word in the definition, 1 corresponds to both 2 and 4. And then last one is number 3, is the relation 1, 1, 2, 1, 3, 1, 4, 1, 5, 1 a function? Explain. So again, 1 is mapped to 1, 2 is mapped to 1, 3 is mapped to 1, 4 is mapped to 1, and 5 is mapped to 1. So everything is mapped to 1. And that's okay, because 1 is not mapped to anything other than 1. 2 is not mapped or corresponds with anything other than 1. So we're actually okay, even though everything gets mapped to or everything corresponds to the same thing. That's okay because it's not being mapped to more than one thing. So we say yes, because, and we can give the exact same explanation as before if we want. Yes, because the domain, remember domain is x values, because the domain does not repeat. It may be boring, they may all go to the same place, but you know where they're going. They're all going to 1. They're not going to 2 different places, like in number 2. Alright, so here we switch modes a little bit, and instead of just looking at a bunch of coordinates, we actually look at something that's graphed. And this is easier, believe it or not. It's much easier. And it's something called the vertical line test. The vertical line test is a really simple way of deciding whether a domain repeats itself, an element of the domain. So it says right here, if you can draw a vertical line through more than one point on a graph, then the relationship is not a function. Or the relation should be relation is not a function. So we have these two examples, function, not a function. All it did was go sideways on us. But you can see if I take this vertical line and I pass it through the function, it's never hitting the function more than one time, no matter where I put it. It's only ever going to hit once. But if I take that same vertical line over here, it hits once right at the point, but every time after that, it hits 2 places. So if I leave it there, it hits here and it hits here, which means, let's say I went over 1, 2, 3 spots. That means there's a coordinate of 3. We'll call that one 3, 4, 5, 6. There's one at 3, 6, and there's one at 1, 2, 3. I don't know if that's 6 again. Let's call it 3, negative 5. So that one's this one. This one's this one. This is the problem: is that 3 repeated itself. 3 could have a y value of 6, or it could have a y value of negative 5, and that makes it not a function. Alright, let's try some more here. So are these functions? Well, the first one, number 4, we already know because it's that same shape. And number 5 we already know because it's that same shape as before too. So we know this is, oh, that's my white marker. This is no. This is yes. And this one here, even though it's a little bit crazier, I still can't ever get it to hit more than once. So this is yes, a function. I keep trying to use my white marker. Yes, and then the last one, I can make it hit quite a few times here. So definitely not a function. Hits here 1, 2, 3, 4 spots. So not a function. Alright, we're going to do a couple brain teasers and then be done. So I have this relation that's almost all there. We have 6, 3, 8, 2, 10, 1, and blank 0, or x0. It says name all possible values that x may not represent if relation A is a function. So we kind of want this to be a function. So if I said, hey, make this a function by putting in a number for x, you could pick lots of different things. There's only a small amount of things that you cannot pick. So x could be, if we wanted to, it could be 100, because we haven't used 100 yet. So 100 could be mapped to 0 because it's not mapped to anything else yet. What we could not use is 6, because 6 is already mapped to 3, or corresponds with 3, so it couldn't also correspond with 0. We couldn't use 8. 8 is already corresponding with 2. And we couldn't use 10 because it's already corresponding with 1. So sometimes you'll be asked like that. You have to kind of think backwards a little. Okay, we're actually going to end it right there. We'll do a little bit of work in class with this. And this is an interesting way of starting our coordinate geometry unit. It gets a lot different from here. We're going to do a lot of graphing lines. We're going to do some word problems that go with that. We're going to learn about what slope and y-intercept mean. So we have a lot to come in this unit. But we're going to start off with some more vocab and just getting ourselves comfortable with some of the language of this unit. All right, have a good night, and I'll see you tomorrow.